Welcome to Notebook 51, Tool Calling. In this notebook, you're going to learn to augment your large language model with the ability to indicate that external non-LLM related functionality ought to be utilized. This is a technique that we refer to as tool use. By the time you complete this notebook, you will understand what a tool is in the context of LLM applications. You'll be able to create tools, and you'll also learn about how model recommendations about when and how to use tools are actually materialized. Per usual, we'll begin with making our imports. Everything here are things that you've seen before, with the exception of the Wikipedia API library that we'll be using for an exercise later in the notebook. The LLM instance that you're creating is the same that you've been creating throughout the workshop. Okay, so let's talk about large language models using tools. Throughout the workshop, we've been exploring some of the very amazing tasks that LLMs are capable of, but of course, they aren't well suited to every single task. Whether it's a task that a model would try to do but probably shouldn't, like math or other calculation-based tasks, for example, or for a task that's downright impossible for an LLM, like making a call to an external service or API. Sometimes when building LLM-based applications, we want to augment those applications to be able to use tools external to the large language model itself. Now, you've done a little bit of this already in the context of creating custom runnables via runnable lambda and including them in your chains. And as we mentioned, these custom runnables can perform arbitrary tasks that are not necessarily using the large language model themselves. However, we're going to look at a different technique, a very powerful technique, where we provide an LLM a kind of awareness around a collection of functions that we're going to be calling tools that might be appropriate to be used depending on the input from the user that the LLM gets. And then we will allow the large language model to actually decide when using one or several of the provided tools will be appropriate. Additionally, we will be using the large language model in the case that it wants to use a tool to provide details about how the tool or tools that it deems appropriate to use ought to be called. A lot of what you learned in the previous section of the workshop around structured data generation is actually highly relevant to how LLM tool calling works. What happens is that the LLM is going to be able to generate output conforming to a very specific structure. And in the case of tool calling, the output structure is going to be the name of a provided tool that actually ought to be called, as well as specifically formatted details representing the argument schema for that tool that indicate exactly how the tool ought to be called. Right? So a lot of what you learned in structured data is going to make your understanding and intuition about how tool use works a lot clearer and easier to understand. Okay, so for us to begin exploring this, we first need to know how to actually create a large language model tool. So probably the easiest way to do this, per usual, LangChain gives us a few different ways, but we're going to stick with the most recommended and highly used, which is with a decorator called tool, which we can apply to a function, and this will convert the function into a tool. So the tool can be imported from LangChain Core Tools, and here we're going to apply the tool decorator to a very simple Python function which we call add. There's nothing fancy going on here. It's an add function that returns, that expects two arguments and returns the sum of the two arguments. Of course, we could do this in other ways in Python, but we're just going to start with some really simple functions so we can focus on the tool construction. I would assume that most of you know about decorators, but in the offhand chance you've never seen this at symbol in Python code. Basically what we're doing is using a special Python syntax called decorator syntax, where above the definition of a function, you can use the at syntax to decorate this function. Under the hood, what's happening, for those of you who are interested, is that when we decorate functions, this tool is actually a function itself, and it's what we call a higher order function, which is just a fancy way of saying a function that accepts and or returns other functions as arguments or return values. And in this case, what's happening is that by decorating the add function, we're actually passing the add function definition into this tool function, and the tool function is then modifying the add function definition and returning a new value for add that, as you'll see, is going to behave a little bit differently than the Python literal add. So again, that's kind of like, let's say, intermediate Python. You don't really need to understand that entirely. Just know that we can decorate functions, and in this case, tool is intended to be used as a decorator. And here we apply it right above the definition of our add function in order to decorate the add function. And as we'll explore presently, the add function has now been modified. It has been decorated and is going to behave in a special ways. Okay, so since add is no longer a Python function, but rather a tool, it has some specific attributes associated with it that we can inspect. And we're going to do that presently. So the first is its name, which, oh, excuse me, I need to actually run this cell first. Okay, so the first is its name, which will give us a string based on the name we used for the decorated Python function. So here, add.name is actually the string add, which matches the function definition itself. These tools also have a description field, and you'll notice that the description field was obtained from the doc string of the function, namely add two numbers. As was the case with Pydantic classes used for structured data output in the previous section, our doc strings are going to be used by LangChain under the hood to convey information to the large language model. And thus, not only is it important to add a meaningful doc string to your tools, but it's in fact required. If you try to decorate a function with the tool decorator and it doesn't have a doc string, you'll get an error telling you that you need to provide it. Okay, so tools also have an args attribute, and because in the case of our simple add tool here, we provided some type hints here about the expected type of the arguments and the expected type of the return value. You can see here that the args attribute, each arg A and B has associated with it some additional information around the type associated with it. So, A should be an integer and B should also be an integer. We're going to look a little bit more at this later. Yeah, so hold tight on that. Okay, so tools are not Python literal functions. They've been decorated and they're different. And with that in mind, when we have a tool, we can't invoke it with the parentheses like this, as we typically would with a vanilla Python function, trying to do so with thrown exceptions. So just to prove that, we have our add tool here, right? We defined it originally as a Python function, but we've decorated it, so it's no longer a vanilla Python function. If we try to invoke it as we would a typical vanilla Python function, you can see that we caught an exception here. It's an attribute error. And you can see that the error says int object has no attribute parent run ID. Okay, so we don't need to worry too much about that particular error message, but the point being is that we can't actually just invoke this tool. Rather, tools, as with many things, as you've seen in the LangChain ecosystem, have invoke methods associated with them, and we use the invoke method to make tool calls, or tool invocations might be more appropriate to say. And when we do that, we always supply a Python dictionary that maps the expected arguments to the values we would like to provide. So in this case, if we invoke the add tool specifying 3 and 5, we know 5 plus 3 is 8. So now it's behaving as we would expect. Okay, so let's look at a slightly different way, and I would claim a slightly better way to define tools. So by using Pydantic classes. So just as we used Pydantic classes in the previous section to articulate the very specific structure of a data type that we wanted the LLM, an LLM's output to conform to, we can also use Pydantic classes to articulate the schema for the arguments that the LLM will recommend that we pass to a given tool. So here we're going to create a new Pydantic class. We are calling it a Pydantic class because just as we did in the structured output section, it is inheriting from base model, which we've imported from Pydantic. So we have here a Pydantic class called add. Okay, so using Pydantic, just as it did in the structured output scenario, gives us a really great deal more of control over the intended structure of a tool's argument schema. This includes things like field validation, default values, and a lot of other things that we won't necessarily go into great detail about in this workshop. You can always learn more about all the different options available to you in using Pydantic if those are interesting to you. But at the least, it gives us a very easy and clean way to specify the schema to the large language model, and also makes it very simple to provide the LLM with additional information, both about how the tool ought to be called, and also to add descriptions to each of the schema's fields. So once again, we're going to define an add class here that's a Pydantic class. We're going to provide a doc string that indicates kind of the main reason why this tool ought to be used. We're indicating use when and if you need to add two numbers. Just like in structured data, this doc string under the hood is going to be part of a prompt that goes to the large language model. So sometimes there needs to be a process of iterative prompt engineering with your doc string to make sure it behaves as expected. But at the very least, always keep in mind that what you write here in the doc string is intended to inform the LLM about when and how it ought to consider using this tool. Furthermore, the add tool has two very simple arguments. They're both integers. As we did with structured data, we're going to use our field function so that we have access to a description field. It's very simple here. We can just say first integer and second integer. But as with the doc string under the hood, whatever we put here in these descriptions are going to be part of a prompt that goes to the large language model. So depending on your use case, you want to take care and be intentional about what you write in these descriptions because they're actually a very important prompt engineering aspect to how the tool gets called. Worth mentioning, this ellipse here and here is just a simple syntax for stating that these are required arguments. Okay, so having defined this Pydantic class that's meant to